This is part 2 of GCSE Revision. This section will be covering ratio and proportion. Just a reminder, if you had seen the first video, anything with a star next to the question will be for calculator. Okay, first question. A, B and C share £120. The ratio of the amount A gets to the amount B gets is in the ratio of 5 to 4. The ratio of the amount B gets to the amount C gets is in the ratio 2 to 3. Work how much each of them get. So this is a split ratio. Okay, so we have A to B, which is 5 to 4, and then B to C, which is 2 to 3. Okay, if you have split ratios and one of them is repeated, what we can do is we can get it all under 1 by finding a common multiple. So a common multiple of 4 and 2 is 8, so I'll times this side by 2 and this side by 4. That gets 10 to 8, and then 8 to 12. So now that B is the same both sides, I can put it all under 1. 10, 8, 12. What we can do is just add all these parts together. So that's 18 add 12, which is 30. So 30 parts in total, and we're dividing those 30 parts into 120. So that is £4 per part. Now we just multiply each of these by 4, so that'll be £40, £32, and 12 times 4 is £48. Okay, that is our ratio, and we are finished. Question number 2. This is a calculator question. Helen's savings increased from £155 to £167.40. Work out the percentage increase in Helen's savings. Okay, percentage increase, we're going from one amount to another. And when this happens, this is a percentage change type question. Okay, the general rule for percentage change is work out a change between the two amounts and then divide it by the original amount. This will get your decimal, and then you just times it by 100 to get your final answer. Okay, so this is percentage change. Okay, so the change in amount is going to be £167.40, take away 155. Now the original is where we're coming from, which is 155. And then just times that by 100, and that will get your final answer. This is 8%. Okay, part B. Joe's savings increased by 4.5%, so we're going up by 4.5%. His savings are now £125.40. What were his savings before? Okay, a lot of my students get these types of questions wrong. What they do is they'll find 4.5% of this amount and then deduct it. But that's really not how this works, because for you to do that, you're assuming that this is worth 100%. Okay, but it's not 100%. 100% is our original amount. So 100% is our original amount. So this type of question is an original amount type question. Okay. Which we don't know how much this is, so I'm just going to put X pounds. Now we are going up by 4.5%, so whatever our original was, we are now increasing by 4.5%. So this becomes 104.5%. And in the question it says this is equal to £125.40. So if we know that, we can easily work out what 1% is, because we could divide both sides by 100. Because I want to work out what 1%, not 100, sorry, 104.5%. Because I want to get to 1%, so I divide by 104.5%. Whatever I do one side, I do to the other side. Okay, now if I divide that by 104.5%, I get £1.20. That's 1%. So that means 100%, which is what we're looking for, remember, because that's the original amount, would be worth £120. And that makes sense because our original amount should be below £125.40, because that's after, this is after going up by 4.5%. And that is finished. Question number 3. A bank pays compound interest at 6% per annum on its savings account. Julia invests £7,500 for 3 years. Calculate the total interest gained. Okay, so this is compound interest. So what that means is if you gain interest after 1 year, the second year you gain interest on the most recent total amount, not the original amount. Okay, so to work compound interest out, I'm going to get the investment, 7,500. And then what you do is you multiply this by the multiplier, which is 6% increase. Okay, so we're going up by 6%. Now this increase as a multiplier would be 1.06. And we're doing this for 3 years. And once we do that, that becomes 8,932.62. But the question is not asking how much amount there is after 3 years. It's asking for the total interest gained. Okay, be very careful with these types of questions. You must read the question carefully. It's total interest gained. So the way that we can show how much interest has been earned is to take away the two amounts, and then we will finish there. Okay, so fairly simple question this is. So 1432.62. That's finished. Question number 4. Ali drove 56 kilometers from Liverpool to Manchester. He then drove 61 kilometers from Manchester to Sheffield. Ali's average speed from Liverpool to Manchester was 70 kilometers per hour. Ali took 75 minutes to drive from Manchester to Sheffield. Work out Ali's average speed for his total drive. Okay. So when you have a speed distance time question and it's split between two types of journeys, the speed, distance and time will be different for each section. So if I want to do Liverpool to Manchester, okay, what might be useful to do here is a speed, distance, time graph. Okay, so I'm going from Liverpool to Manchester, but what I can do is I can do this in a table instead. So we're going to have speed, distance, and time. And I'm going to go from Liverpool to Manchester. Then obviously the next journey is Manchester to Sheffield. And I'm just going to draw this table in. Okay, so the speed from Liverpool to Manchester, do we know that? No, but we do know the distance. It is 56 kilometers. Okay. Oh, no, we do know the average speed. It says in the second paragraph it's 70. Okay. Ali took 75 minutes to drive from Manchester to Sheffield. So time, 75 minutes. However, you don't want to use minutes here. You want to use hours because the units of speed is kilometers per hour. So I'm just going to get this 75 minutes and convert it into hours. Okay, so we know that there's 60 minutes per hour. So this would be 75 over 60. And this will give us our hours. Okay, that's 1.25 hours. So now I can put this into time. Okay, I can work out the time from Liverpool to Manchester. Okay, I'm going to draw in the speed, distance, and time formula. Okay, this is our formula triangle, and then what I want to work out is time. Remember, if you want whatever you want to work out, you just cover it up. And what we're left with, distance divided by speed. So time equals distance upon speed. Now the distance here is 56 kilometers per hour and our speed is 70. Okay, now if we do that, we get 0.8 hours. Okay. So we want the total average, we want the average speed by the end. So what I'm going to do is I'm just going to extend this. Okay, and this is going to be our average speed for the total. Okay. Or what I can do actually is I'm going to call this total instead, not average. So we'll call this total. Okay, so next bit is what else do we need? He drove 61 kilometers from Manchester to Sheffield. So we know the distance here is 61 kilometers. Okay, if you want to work out average speed, it's total distance divided by total time. In other words, I can add the two times together, and what I will get is 2.05 hours. That total distance is 117 kilometers. Now we don't know the speed from Manchester to Sheffield, but actually it doesn't matter. We could work out the speed if we wanted to, but even if I did work out the speed, it's not like I total the two speeds together to get the average speed. That's not how this works. Remember, the average is total distance over total time, and I have that now. So the total distance will be 117 over 2.05. Okay, then once we do that, we get 57.1 kilometers per hour. That's done. Okay, so this is an exchange rates question. 3 companies sell the same type of furniture. The price of furniture is what we can see the prices here. This is in London, Paris, and New York, and then we give it some exchange rates. Which company offers the best value? So if it's an exchange rates question, it will be a good idea to put everything under one currency. So I'm going to just put it all in Great British Pounds. So that's going to be 1,480 in London. Just leave that there. Okay, so what about Paris? Let's deal with Paris. Okay, so that's London. Okay, so Paris, we know that the exchange rate is, well, it's using euros. So £1 equals 1.34 euros. Now we know the price point in Paris is 1,980. Okay, so we're looking for what is that in pounds. Well, how do I get from here to here? What I can do is I can divide 1,980 by 1.34. This will give me my multiplier. Okay, now if I do that, I get 1,477. So to get from 1.34 to 1,980, it will be a multiplier of 1,477.61. And whenever it's one side, I do it to the other. That'll be 1,477.61. So that is our pounds in Paris. Let's do New York. So £1 is equal to $1.52, and we're going to do the same thing. Now, how much is it in New York? It is 2,250, and then how do I work out the multiplier? Again, just divide 2,250 by $1.52, and if we do that, we get £1,480. Well, that's what it will be because it's our multiplier. Whatever it's one side, it do to this side. So this will be times 1,480.26. So as you can see, that's just £1,480.26. Okay, so now we're just looking, well, which has the better value if we compare in pounds, and it looks like Paris is the better value. Finished. Question number 6. Jelena left her home at 10 to cycle to a park. On her way to the park, she stopped at a friend's house and then continued her journey to the park. Here's a distance time graph for her journey to the park. Okay, so just to have a look here, she clearly left at 10 a.m. as the question said, and then she's moving a distance of 15 kilometers to 11 a.m. Okay, so we could work out the speed here by using our speed as time again. If the line is horizontal, that means it's at rest, and then you can see she's going up again. She's continuing her journey. Okay, so let's just see what question A is. On her journey to the park, did Jelena cycle at faster speed before or after she stopped at her friend's house? Give a reason for your answer. Okay, well, what we can do is just simply say before stopping, she was covering a distance of 15. And that was for 1 hour. Okay, so I can say here that before stopping, I can just measure the gradient of a distance time graph is going to be its speed. So 15 kilometers divided by 1 hour is just 15 kilometers per hour. Okay, now after stopping, okay, we can just measure the gradient. So we're going from 24, and we're going to go from 24, so that's 24 at this point, and at this point here, that's 15. So remember, the gradient is change in y over change in x. So our change in y is between 24 and 15. Okay, Now over change in x, so this is at this point, so what would that be? So we're going from 11:50, that's 15, so each little block is 15 minutes, just to double check, 15, 30, 45, 60. Yep, so between these 2 points, that's 15, and this is 12, so that's 45 minutes. Remember, we're using hours, so 45 minutes, that is going to be 3/4 of an hour. And then if you put that into your calculator, you get 12 kilometers per hour. So before stopping at a greater speed. Okay, so next question. Julian has stayed at the park for 45 minutes. Okay, so that's going to be a horizontal line if she's at rest. Okay, so if she's at rest at that point, that's for 45 minutes. She then cycled back without stopping at a constant speed of 16 kilometers per hour from the park back to home. Show all this information on a distance time graph. Well, first of all, we know that she was at rest for 45 minutes at this point. So let's get a line tool. So if she's at 45, remember at this point it's at 12. So we're going to go across by 45 minutes. And that'll be 12:45, which will be this point there. Okay, the next bit is we need to work out when she's traveling back or distance from home. Okay, so the distance at this point on part B, the distance here is, well, how far is she away from home? So at this point here, we're at 24. We're at 24 kilometers at this point. Okay, so the distance is 24. And our speed is 16 kilometers per hour. Let's get speed, distance, time, triangle formula again. And what we want to work out is the time, because we want to connect the line on the diagram. So we need to work out how long is it going to take. Okay, so time will be distance upon speed, so 24 divided by 16. If we do 24 divided by 16, we get 1.5 hours. So I know that from this point, remember this point is where we're here. So if we want to find where we need to finish on the timeline, remember at this point is 12:45. So 1 hour and a half. This will be 1 hour. So then a half will be 15, so this will be there. Okay, so now all I do now is just connect the line. Right, that's done. Question number 7. Change a speed of 630 kilometers per hour to a speed in meters per second. Okay, these sorts of questions do cause a little bit of confusion. But what you want to do is just take your time, just do one step at a time. Change one thing at a time if need be. So we want to work out meters per second. So this is kilometers per 1 hour. Okay, that's where we are at the start. We want to work out what this will be in speed in seconds. Okay, so what we need to work out is just change the hours perhaps first. We can start with that one. Now this is 1 hour. Now how many seconds are there in an hour? Well, 1 hour has 60 minutes, which has 60 seconds per minute. Okay, so this will be 3,600 seconds. So 630 kilometers equals 3,600 seconds. What I can do next is I could work out, well, how many kilometers, well, meters in kilometers, 1,000. So 630,000. So 630,000 meters is equal to 3,600 seconds. Okay. But we want to work out what its speed is in 1 second. So 1 second, I need to divide. To get to 1 second, I need to divide 3,600. And whenever I do to one side, I do to the other side. And then if we do that, we get 175 meters. Okay, so that will be our final answer, 175 meters per second. And that's done. Question number 8, we have a density volume and mass question. And we are given two materials which are given density for both. And it's then also told us the mass per material, and we want to work out the new material C. Just like the speed, distance, and time question I did earlier, this is going to be very similar. And what I want to do is I want to make a table because again, it'll make so much easier. Okay, so material A. Let's call this A there, B and C. Okay, so what we want is mass. Well, I put density first. Density, mass, and volume. Okay. Now what I want is I want to work out what each one is, but we are given some information. So I'm going to say that this is the mass, this is density. Now what I'll do is I'll do it in the same order as what this is. So this is going to be density first, this is mass, and this is volume. Okay. Now let's just write in what we have. We have density for A and B, so that's 5.8 grams per centimeter cubed. This is 4.1 grams per centimeter cubed. We have the mass of A is 377 g. We have the mass of B, which is 1.64 kg. But actually, I want to change this into grams because if you notice the density units is grams per centimeter cubed, so we have to be consistent. So that would be, what is 1,000 grams? So times it by 1,000. So it'd be 164 grams. 1640 grams. Okay. Now with C, we can total the mass and we can total the volume. However, you cannot just total the density for C. That does not work. We can't just add 5.8, add 4.1. So what we need to do is work out the total mass, and if we work out the total mass, that would be 2017 G. Okay, and the volume is going to be, well, we can work out the volume for each one. So for A, so A volume equals, now volume is mass upon density, so this will be 377 divided by 5.8, and the same with B, the volume, mass upon density, so that's going to be 1640 divided by 4.1. Okay, now if we work out both of those, we get 65 centimeter cubed for A, and for B, we get 400 centimeter cubed. Just going to fill this in. So you can work out a total volume now. That's going to be 465 centimeter cubed. Right, so now lastly for C, we will work out density for C. So this will be, how to work out density is mass upon volume. And we can do that very easily now because of the information in the table allows us to do so. And if we do that, that's 4.34 grams per centimeter cubed. It's finished. Question number 9. The diagram shows two solid spheres. Sphere A is made of gold with density 19.3 grams per centimeter cubed, and sphere B is made of silver with a density of 10.5 grams per centimeter cubed. Which sphere has the greater mass? You must show how you got to your answer. Okay, so let's work out the volume for each one first. It is talking about the mass, but let's talk about the volume for each one first. So A, vol. Okay, so remember we're using our volume of sphere here, which is told us it's 4 over 3 pi r cubed. You might not be able to see that as well, but that's what the volume is for a sphere. Okay, so just fill in what we have. So 4 over 3 times pi times the radius, and the radius for A is 2, so that's 2 cubed. And if we do that, we get 32 over 3 pi. Remember, this is a calculator question, but you want to leave it into pi because that's the exact form. And it's easier to deal with the exact form than decimals at this moment in time. Let's do B, volume. Okay, that's going to be 4 over 3 times pi. Now the radius is 3. So 3 cubed, and if we do that, we get 36 pi. Okay, so which has a greater mass? Now we're using density, mass, and volume again. Remember to get m, or I'll write it down here. You can see to get m, we need to do density times volume. Right, let's start off with A. We're going to do density times volume. So our density for A is 19.3. Let's times that by 32/3 pi. Okay, now if we do that, we get 646.75 grams. Let's do the same for B, the exact same thing, density times volume. Now the volume was 36 pi and the density is 10.5. Okay, now if we do that, we get 1187.52. And that's G. Now we can clearly see which has a greater mass. B has the greater mass. Done. Question number 10. This is a non-calculator and this is a direct or indirect proportion type question. H is inversely proportional to P. P is directly proportional to root of T. Now what I like to do is, as soon as I see these sentences, I just like to create equations. So H is inversely, so this is a proportional sign. Now if it's inverse, it's going to be 1 over every single time. 1 over P, because it's indirect or inverse. Okay, now I could build off this by saying this is H is equal to K over P. Okay, where K is our constant to be found. Right, so that is our equation for H. I'm just going to leave that there. And it says in the question, it says given that H equals 10, T is 144, when P is 6. So what I can do here is I can work out the value of K by inserting the values of 10, and K, I'll leave that alone because that's what I'm trying to find, and P is 6. Multiply the 6 by 10, and this is K. That means our formula for H is equal to 60 over P. Okay, now I'm going to just box this off because I know this is very important. And I'm going to go again, but I'm going to go with P. P is directly proportional to square root of T. Now if I start to turn this into an equation, I can remove the proportional sign to equals K times the root of T. And again, what it's saying here is that P is 6 when T is 144. Root 144 is 12, so 6 equals 12K. Solve for K, so we're going to divide by 12. So half is equal to K, or 0.5. So go back to this question. For P, we're going to say P is equal to 0.5 square root of T. And this is very important because we've got the constant K. Now what this question is saying is find a formula for H in terms of T. So we want H to equal something T. So like AT, BT or XT. That's what it means. So H equals, so let's go back to H. Now it wants it in terms of T. Now if we go back to here, I want to work out what T is here. I want to solve for T. Okay, so, yeah, that's what I want to do. Okay, so how do we do this then? Well, if you notice, do I need to rearrange for T? No, I don't, because if H is equal to 60 over P, we have an expression for P here, it's 0.5 root of T. That means I can get a formula for H in terms of P because I could just replace this with 0.5 root T. Okay, so remember P is 0.5 root T, so I could just swap that out for the expression and this is what I get. Now this does answer the question and I can finish there. What I could do, if you wanted to, I could times top and bottom by root T. This will remove the root at the bottom if you wanted to, but again, it's not, you don't have to. So this would be 60 over 0.5 root T times top and bottom by root T. So I'm just thinking back to surds, really, when we remove the surd at the bottom, or in this case, the square roots. So this would just be 0.05t. But again, you don't have to do that. We could finish there. Question 11. There are three spheres, P, Q, and R. The volume of sphere Q is 50% more than volume of sphere P. The volume of sphere R is 50% more than volume of Q. Find the volume of sphere P as a fraction of the volume of sphere R. Okay. So with this one, it is saying there's three spheres. Okay, we have P, we have Q, and then we have R. Now we don't know the actual numerical value of the volume for any of them. What we can say though is we could say for the value for each one, let's start with P because everything is bouncing off P because the first line says Q is 50% more than P. Now again, it's dealing with proportions, so it doesn't matter what the actual numerical value is. The fraction will be the same throughout. I'm going to say this is just worth 1. It could be 1 anything. Okay. Now 50% more than 1, well, we would just times that by 1.5. 1 times 1.5 is just 1.5. And then R is 50% more than Q. So again, we're just going to times by 1.5. This is our 50% increase as we go along. Okay. Now, 1.5 times 1.5, what is that? So this is going back to multiplying the decimals. So 15 times 15. Just work this out very quickly. Okay, that's 225. Put the decimal back in. We are 2 places in from the end because it's 1, 2 places. So that would be 2.25. Right, so what does it say next? Find the volume of sphere P as a fraction of R. Okay, as a fraction of R. Well, that's just going to be 1, which is P, as a fraction of R, which is 2.25. Okay. What we could do here is I could times top and bottom by 100 just to sort out the decimal points at the bottom. This will just make it a bit easy to deal with because you would probably get this 1 over 2.25. You should get that because it's not asking us to leave it in a certain way, but I like to just make fractions a bit easy if they're a bit messy. Now this, if we cancel this down, this will be 20 over 45. Then we can cancel that down again as 4 over 9. Okay, and that's finished. Question number 12. We just have some split ratios again, but the way it's presented is different than our first question. So 2a to 5c equals 6 to 25. Okay. Now, what I can do here is I can write this in fraction form. 2a over 5c equals 6 over 25. Just a quick reminder, if we have a to b, that can be written in the form of a over b. And that's what I've done here. Okay, so what I'm going to do next is I'm going to times out the 5c to the right-hand side, and I'm going to do the same with the 25 to the left-hand side. This will make it much more easy to deal with. So this will be 50a equals 30c. Okay, so now that I've got that, I could write that in another form. Okay, if I divide by c, so a to c equals, and then divide by 50, this would be 30 over 50. Now again, notice how a to b, notice the format. A to c will be equal to 30 to 50. Okay, that's what's happening here. Okay. What I can do is I can divide through by 10, and that's 3 to 5. Okay, that's A to C done. And what we're going to do the same with B to C. 4b to 7c equals 20 to 21. Okay. Then what I'm going to do is again just put it in fraction form. Just be wary of what we're trying to find by the end. But I didn't really mention any of this because I want to work out what the ratio is in terms of A, B, and C. We will get onto that because obviously we need to answer that question. So 4b to 7c equals 20 over 21. Times out the denominators like we did before. Now 4 times 21, that's 84. So 84b B is equal to 140C. B to C equals 140 over 84. So B to C is equal to, now if we cancel down 140 to 84, we get 25 over 15, or 25 to 15. Okay. Now we could cancel that down as well if we wanted to, so that would be 5 to 3. So that's what B to C is. Right, so I'm just going to box both of these because these are obviously very important. Okay. Now we are pretty much where we were at the first question. We have A to C, which is 3 to 5, and then we have B to C, which is 5 to 3. Now this is a split ratio problem again, but what we can do is find what the repeating part is, which is C, and then work out a common multiple, which is 15. So I can times this side by 5 and this side by 3. This makes it 9 to 15. Sorry, I'll do B first. So 9, not 9 to 15. 9, so this would be 9 to 15. This would be 25 to 15. Okay, so now this will be 9 for A. B will be 25 and C is 15. That's A to B to C. Okay, that's what we have, and that is our simplest form. What we could do next is just answer the question. So A plus B to B plus C is that 70 to 20? Well, let's check. A to B, so 9 add 25. B to C, 25 add 15. Okay, so this becomes 34 and this becomes 40. Now we can cancel this down by a factor of 2, that's 17 to 20. And if you notice, that is exactly what it was asking for in the question. And we've proved that, so we are finished. Number 13. This is another compound interest question, but it's a little bit more tricky. What annual percentage rate compounded annually is needed so that Chloe can receive 4,200 after investing £3,150 for 4 years? So annual percentage rates, okay, so X percent. We don't know. We're trying to find that actually. Okay, so she's investing £3,150. And now we would times this by the multiplier, but the thing is, we don't know what that multiplier is. Remember, this X percent, if it's going up, we have to add 1. Like, so for example, if we were going up by 4%, our multiplier would be 1.04. So we need to add that 1. Now that 4% is 4 over 100. Okay, so that 4 over 100 would be 0.04. But we add in 1 because we've shown an increase of 4%. So that's why we're always going to add 1. So 1 add X over 100. Again, we don't know what that percentage is. And we know we're doing it for 4 years. And what do we want to get? We want to get 4,200. Okay, so this now becomes a solving problem. I'm going to divide both sides by 3,150. So this just leaves us with the brackets on the left-hand side. So if I do 4,200 divided by 3,150, I get 4 over 3. Next thing I want to do is I want to sort out the power of 4. Now, to do the opposite power of 4, we 4 root both sides. That means the power on the left-hand side will go. Now, if I 4 root 4 over 3, what do I get? Well, this is a calculator question, so what I can do here is 4 root both sides, and then, no, actually, what I'm going to do is I'm going to times out the 100. You can 4 root, of course, but what I'm going to do is I'm just going to times out the 100. So whatever I do to one side, I do to the other side. And I am also going to 4 root the 4 over 3. So times out the 100, remember if we do that, this 100 will affect this number as well. So do be careful when you're solving, when you're timesing out. So that's going to be 100 plus X equals, now remember you times 100 both sides. And once you do that, this would be 107.456 and so on. And then to get X on its own, remember that's what we're looking for. Take away 100 both sides. So this would be 7.46. Okay, so that would be our answers x is equal to 7.46%. Okay. Remember, that's what we were looking for here, x percent, and we now do have that. Okay, so that is our final answer, 7.46. That's done. Question 14, this is our last question. One of the attractions at a theme park is a roller coaster. The graph shows the velocity of the roller coaster in meters per second for the first 14 seconds. Okay, so just going to zoom in a bit further. Calculating kilometers per hour, the velocity of the roller coaster at time t equals 4. Well, all we need to do here is just go from t equals 4. Now, you should use a ruler for this one, but because the lines are pretty thick on this software, I'm just going to use dashes to get me the velocity. But you should use a ruler, and really what you should do is just go like that with your ruler, and then go to the side to see the velocity, and leave your marks in, because if you do read the wrong time, you'll still get method marks for this. Okay, so we're looking at that point there. So what is it at that point there? That looks like, well, it looks like it's going up in 2 little blocks is 1 unit, so 1, 2, 3, 4. So this is going to be 24 meters per second. Okay, part B, calculate an estimation for the acceleration of the roller coaster at time equals 2 seconds. Give you an answer in meters per second. So in a velocity time graph, the acceleration is the gradient. Now, if we want to work out a gradient for a curved graph, we need to draw a tangent because we measure the gradient based on a straight line. Now, we want it at t equals 2. That's at that point there. So in a real exam, you would have balanced your ruler as close to that as possible to create a line. So, for example, I think this should be okay. Yeah, that looks good. And then what you would do is you would find a gradient at this point. You'd use your ruler again to work out change y over change in x. It's a little bit awkward for me, so I'm going to do it without. So change in y is 25, take away 10, which is going to be 15. Now the change in x, we're going, let's say it was there originally, and I think, let's see, these little boxes out here, that's 0.4, 0.8. No, we're not going up in 4s. 2, 4, 6, 8, 10. Yeah, we're going in 0.2s. So at this point, this is 0.2, 0.4, 0.6. And at this point here is there 2.2, 2.4, 2.6, 2.8. So 2.8. So this will be 15 over. Now let's just work out what this is going to be. So 2.8 take away 0.6 is that is going to be 2.2, and let's just finally work this out, and that'll be 6.82 meters per second, and that's our final answer actually for part B. So that's done. C. Use 5 vertical strips of equal width to calculate an estimate for the distance the roller coaster travelled between t equals 4 and t equals 14 seconds. Okay, so I'm just going to get rid of all of this. Okay, so basically the velocity time graph, the area underneath the graph is the distance. So I'm just going to write that here. So area under the graph equals our distance. Okay, so we want equal width between 4 and where do we want to go up to? 14. So 4 to 14. How many does it want? 5 equal strips. Well, our length in total is 10. 40 take away 4 is 10, but we want to divide by 5 equal strips. So this would be 2. So what it's saying is that we need to go 2 units for every single strip. Okay. So I'm just going to draw those straight lines in. So we're going to go from there to here. And then we're going to go from there to there. Let's do that a little bit better. So we're going to go from there to there, and there to there. and then just nearly there. Okay, so we want to work out A, B, C, D, and E. So remember, this is trapeziums. Okay, if you notice these shapes are trapeziums. Now the area of a trapezium is A plus B divided by 2 times the vertical height. Now it does give you that in the formula book at the start of the paper. Now I'm just going to work these out, but I'm not going to go through all of them because it'll just take too much time at this point. But I'm just going to work out A, then I'll skip ahead for the final one, then we'll get a total answer. So E, for example, so remember A plus B, so this is going to be the two parallel sides. We're going at this point and this point like that. So this is, now what is this going up in? It's going up in points. Now, so the 21, 22, 23, 24, yep, okay, so 2 units is 1. So this is 24. That's going to be, that length is 24 plus, that's going to be 21.5. Okay, 21.5. Now divide this by 2, then times by the vertical height. The vertical height is that part there, which is 2. And if I do that, I get 45.5. I'm just going to go ahead and do this for all of these, but that's how you would work it out. So I've done all of these now. I've done B, C, D, and E. I did it exactly the way that I did it for A, using the trapezium formula. And these are all kilometers. So our final answer for all of these, once we add all of these together, we get 175 kilometers. Okay, and that is our final question and our final answer. I hope this has been helpful, and part 3 is coming up soon.